All right, hello everyone, and welcome to Typescript. Whether it's your first time talking about TypeScript or your third time talking about TypeScript, I think we're going to have a good time together. So let's start by kind of overviewing what TS is all about. So TypeScript is a typed superset of JavaScript. So that means if this is JavaScript, this is TypeScript. TypeScript is all of JavaScript plus a couple of other things. What it does is adds type safety to JavaScript. Who can give me a good definition of what type safety is? Give it a shot.
I'm assuming you mean like if you expect a string, the only thing that can be returned is a string and it'll like, I guess, toss an error if it gets any other data type.
Bingo! Great definition of type safety. So if you try to use a string somewhere that's expecting a number, you get an error. Now, you get a particular kind of error. Who can tell me what sort of error I get?
Type error?
It is a type
Oh.
error. That is like the type of error which is in a larger category called
Compile error.
compile time errors. So if you use the wrong type, you get a compile time error. Parnell, give me a rundown of compile time versus runtime.
Compile time happens when the interpreter is compiling the code. Runtime is when the code is actually being ran.
Bingo. We like compile time errors because that's the fastest feedback loop. Um, if we can find out immediately that something's broken before anybody even runs the code, that helps us write higher quality code. If we can't find an error until the code is actually being run, maybe you catch it, maybe the tests catch it, maybe your users catch it. Oops. So type safety helps us catch our errors earlier. So that process of compiling, that's part of this too. You write TypeScript, a type checker looks at your TypeScript code, rips out the types, turns it into JavaScript. So there's this extra step in here. Normally we write JavaScript, throw it in the browser, call it good. With TypeScript, we write TypeScript, we run it through the type checker, which makes sure that our code is type safe. And if it is, it gets rid of all the type code because your browser doesn't understand type code.
How does it know what types they are?
Great question. So for some of them, you annotate them. So you say, by the way, this variable is a string, just so you know. Other things are inferred. So if I say, let a string equal whatever, the type checker knows that this is a string because I told it so. This is called an annotation. Letting the type checker know that this is a string. Now, TypeScript can infer that a lot. So if I say, let B equal thing, the type checker assumes that the type of B is a string because that's what you assign to it. If you use const, it gets even better. If you used const, this can't be reassigned. So not only is it a string, it's this specific string. So that's one way that it does it. Most of the time it can infer your types from how you're using them. One place where it generally can't do that is with a function definition. It usually can't figure out what these parameters are supposed to be. So those you usually have to annotate. But the advantage of that is when you annotate those and try to call it, it will type check your stuff in real time. So if you do that, not a problem. If you get those backward, it'll go, hey, this first one's supposed to be a string. This one's supposed to be a number. Sharon, does that answer your question?
Thank you.
Other questions about the TypeScript to type checker to JavaScript process?
For variables, since it can infer that most of the time, I mean, what would be the real purpose of annotating it? I mean, is that if, it's throwing an error to go in there and annotate it?
So this is a little bit counterintuitive when you're newer to programming, but type safety, and the reason it's counterintuitive is this is going to bug the shit out of you for a couple of weeks. Type safety will just constantly tell you how wrong your code is. But the advantage of all this is we get more confidence. That we have fewer errors in our code because rather than get a whole bunch of bug reports from our users, it's like getting those as you're writing the code from the type checker. Now, if TypeScript can infer something, you're probably better off leaving it alone. So the reason that you might annotate a type is you want it to be narrower or more specific. So for example, if I do something like have a list of colors, and I go that I want a type called color that is equal to red or green or blue. So that's a type. It's narrower than string. String can be any string. This color type can be one of those. So if I make a variable called like accent, and I set that equal to red, the type checker will infer that this is a string. I can make it more choosy than that by annotating it as a color. I guess in this case it would be narrowed down to the string red anyway, but this will catch problems like, oh, sorry, you put yellow in here and that's not one of the allowed colors. I actually do that a ton on the LMS. So all of these labels are part of one giant ass type that has every single post in the entire program. So if I try to add one that's like Parnell Party, it barks at me and goes, hey, Parnell Party isn't assignable to slug. because the slugs are a list of every one of the things that I have. That's a type checker telling me that, like, hey, that's going to be a problem. But, like, this surprises people, I think, the most when they're getting started with TypeScript. You don't have to annotate that much. You just get, like, all kinds of better hinting and information about your code basically for free. You have to annotate your function parameters, and there's a couple of other things. Some of you have figured out that like typing promises, it's a little bit more difficult, or a couple other situations where we'll have to mark something up. But a lot of the time, we just get better editor tooling and better error messages with very little extra work.
Is this the same as the jest testing where your code is created in the Typescript file?
So yeah, you write a TypeScript file, and then you compile that into JavaScript. Now, like Jest, you can do that with like a watch, so that every time you update the TypeScript file, it like poops out another JavaScript file. There's a few different ways you can do that. But yes. More questions so far? Cool. Let's head over to Code Sandbox. We should open up a vanilla Code Sandbox. Oops. And then we can delete everything in this JavaScript file. Then I want you to do a couple things. One, I want you to change the name of index.js to index.ts. I want you to grab a reference to the app. It's a built-in element to this file. It's document.querySelector app. Over here, we need to change this to TS also. All right. So take a second, get caught up, get this far. It's a vanilla app. Change index.js to index.ts there. And in your JavaScript file, grab a reference to the app. Take a sec.
I was looking away. What did you end up putting in the HTML? Sorry. You said a reference to the app?
Yeah, he was just saying update your JavaScript to TS instead of JS.
Oh, just that. Okay, cool. Thanks.
Now, the reason we can do all this in place is because the vanilla template in Code Sandbox uses Parcel. Parcel can automatically interpret TypeScript files and like do the transpilation in real time. So we don't need to do it as a separate step.
Do we have to do the HTML development thing in like the brackets?
What do you mean?
Like
To type it.
Yeah.
You don't have to. So
Okay.
if you don't do the generic here, for anybody who's like done a little bit of TypeScript already, normally when you're using query selector, you'd also want to put like HTML div element in there. Not required. If you don't do that, it assumes that it's just an HTML element, not any particular type. That's not a problem because div elements aren't all that special anyway. But the reason that you would type that, Parnell, is like if this was an input, like inputs have attributes that are allowed on them that aren't allowed on other things, or forms. Like forms have submit events. Divs don't have submit events. So it can be helpful to like, type that a little bit more narrow.
Okay.
But if you don't, it just defaults it to HTML element. All right, give me a thumbs up if your screen looks like my screen. Scott, Parnell, Tiffany, Matt, Amp, Brad, Matt P, Blair, Sharon, Sarah, Chris, Efren, Julie, Lauren, and I'm going to guess Sean. All right. So let's write our first TypeScript code. Let's do the add example. It's a nice, easy one. So we're going to make a function called add that takes in number 1, number 2, and returns their sum. Cool. So that's just regular old JavaScript. No like type stuff needed. So to start annotating types on this, you postfix them. So postfix is the opposite of prefix. There are languages where you put the type first. TypeScript, you put the type after, whatever the thing is called. So number 1 is a number. Number 2 is a number. Ta-da! TypeScript. So the advantage of that is if I try using this, 1 plus 2, no problem. If I try to make that the string 1 and 2, womp womp. Argument of type string is not assignable to parameter of type number. That's a string. That said it was expecting a number, so it barks at me. It won't work. That's TypeScript in a nutshell. Ask me some questions.
Question semi-rhetorical, but it can't be that easy, can it?
Yep. Now, like, there's more to it, especially when we start talking about the types of objects and, like, the real brain fuck, the types of functions. But, like, a lot of your, like, minute-to-minute TypeScript code is just JavaScript and it infers the types.
So, would you, I guess, in a real life situation?
Oh, sorry, Lauren, I can't hear you.
Sorry, is this any better?
Yes.
Okay, closer. So, in a real life situation, would you go through and just write a JavaScript file and go back and add the TypeScript stuff?
No, what you'd really do is add the types as you get yelled at about them. So since we're using parcel and we don't have a TypeScript config, it's not going to yell at us. But if I was doing this on the terminal, check this out. So don't follow along with this. I have a video that does step by step on how to do this on the on your terminal. But if I initialize a npm project and I install Typescript, and I run npx tsc init, that gives me like a default TypeScript configuration with this strict true. That's the one where it yells at you all the time about everything. That's what we don't have on our code sandbox. If I make an index.ts file and try to do that same add function, it's already yelling at me because it's saying that this implicitly has an any type. Any type means untyped. And strict mode, implicit any's are not allowed. So that's when you would add it back in. Yeah, if we look at like my LMS code. Okay, so this is all TypeScript. No types. This one is typing the argument, the function to filter. Other than that, no special types. This one is typing a parameter, otherwise nothing special. Typing a parameter, otherwise no annotations. Typing a parameter to a function, no types, no types. This one is defining like a big type. That's basically this whole file is this type. This is the thing I was talking with Parnell about a second ago. They're called generics. Making a type that I can use. Annotating a parameter. Generic. Generic. Anytime I have a function, I'm typing the parameters. Otherwise, not much. Typing the parameter. Typing the parameter. This one, I didn't even have to type the parameter because it was able to infer it from the thing that I'm mapping over. Same thing here. It knows what the type of evaluations is, so it doesn't need me to say what each specific one is. There you go.
How do you know whether to use Jest or TypeScript? And
I'm sorry, I lost that.
how do you know which testing to use, like Jest or TypeScript, or do you use both?
So both Jest and TypeScript help the quality of our code super different ways. What TypeScript makes sure that the structure of our code is sane. Jest asserts that the behavior of our code is what we expect. So, for example, if I go back to that add function, or here, I'll go to one up here.
Using both applications on the same function to test different aspects of it?
100%. So TypeScript can make sure that this is only ever given numbers. What it can't protect against is that happening. TypeScript doesn't say what the code should do. That's what your tests do.
That makes a whole lot more sense.
Excellent.
Since you know that.
So yeah, and like without TypeScript, we would have had to write a lot more tests to make sure that like it acts the way that we want it to act if it's given the wrong values. TypeScript, we can just prevent it from being given the wrong values at all. And so you'll find that in typed code, you end up writing way, way fewer tests. And the tests that you do write end up being very specific to like, do the inputs turn into the outputs in the way that I want?
I guess another crazy part for me is that you can define your own type like we did for the accent color.
Yeah.
That's where it like really starts to get like, I wonder what kind of possibilities you can, do with that.
All right, so let's take a look at an example from like long ago. The code analysis 15. All right. So this was the function. And so this one took a person object and a pet name string. That person was expected to have dogs. And for each dog, if that dog's name equaled the string, then we returned the dog object. So that was one of those code analysis things we did. So we'll call this like find dog. Okay, so first thing that I want to do is type these. The pet name's pretty easy. It's a string. This person, though, the person's an object that has dog properties. The dogs is an array of strings. Yikes. So what we can do is we can make our own type for that. We can make a type called person that, I don't know, maybe it's got a name that's a string, an age that's a number. Could be anything. What we really need, though, is this dogs thing. So we say that it has a dogs property that's an array of strings. That's how you write that. Whatever the type is with square brackets next to it, that just means an array of these. Cool. So now I can say that person is of type person. Notice that this is capital P. Types are generally Pascal cased, so every word in them is capitalized. Also notice that this looks an awful lot like object syntax, except not quite. These have to be types, not values, and they end in semicolons, not commas. Looks kind of like an object, isn't actually an object. So then if I make an actual person type, or person value, I could say Kyle is name, Kyle, age 4, and my dogs are Bixby and Harmony. And if I type this, if I explicitly annotate it, it'll even tell me whether or not I got it right. So like if I did this as this age as a string instead, I go, whoa, 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 whoa. String isn't assignable to type number. You said age was a number. You put a string here. All right, thanks, TypeScript. Or if I accidentally do this as an array of objects, where I say, all right, well, the dog is an object with the name Bixby. Hey, why is it so mad at me? Type object with a name property with a string value is not assignable to type string. Because I said I'm looking for an array of strings, not an array of these dog objects. But one of the reasons that we don't actually need to annotate that is we'll find out soon enough, as soon as we try to use this. So I can say like, find dog Kyle, and then if Kyle wasn't a person object, that annotation would catch it and go, it just needs to be a person. And I'm looking for Bixby. Oh no, I got this wrong. Dog is an object. See, it even caught it for me. Property name does not exist on type string. Since I'm trying to get the name property of this dog, that means it's not actually a string. All right, so then maybe I make another type for that. Dog is something with a name property. And so then this can be an array of dogs. These hoist like function definitions do, so it doesn't matter that these are declared out of order. They're declarations. So then it'll go, hey, this thing that you gave me, that's not right. Because the dogs is an array of strings, and the property dogs is incompatible. So it is. So if I fix that, all of a sudden nobody's mad at me anymore. And I could say something like, get the name, assign it to app.textContent. Now it's on the page. If I get any part of this wrong, like leaving off property, womp womp, all falls apart. Tells me right away. So we can make our own types with this type keyword, and this is mostly for objects. You can also use it in a couple of other situations, but that's sort of the bread and butter. And this is where this starts getting more complicated.
I have a question.
Strings and numbers and Booleans. Yes.
Oh, okay. So, say for example, on like your Kyle object, say what if I had like height, right? So another property, but you didn't include it in your alias. I notice it doesn't give you an error. Is that okay to do?
Yeah, it's that depends. So that's the excess property checking thing. So if I do something else, that's usually not a problem. And here's why. What TypeScript cares about is that I can call name and age and dogs. And so what it's going to look for in here is that I'm only ever doing things like trying to get a dog's name or trying to get a person's dog's property. Since I'm never accessing something else on this, that's kind of not a problem. It can have more. It just needs to have everything that this type guarantees that it does. But I'll bet if I explicitly annotate this, it might bark at me. Let's see. Yeah, see? If I explicitly annotate it as person, that's when the excess property checking fires off. And this is that structural typing thing. There I said it was a person, and so it's going to check to see that it conforms to all of this. Here, it really just needs to have the things that a person has. If I have another type or if I have values that have all these things, but I didn't explicitly type them as a person, or I type them as something else that also has all of these characteristics, TypeScript doesn't give a shit. That's like the single most powerful thing about TypeScript. Now, if structural typing and nominal typing doesn't make any sense to you, move on with your life. Like, it's not that important to understand. But it is what makes TypeScript cool. And the difference will probably make more sense when we do Java, because Java is nominally typed. But as it is, when I pass Kyle into find dog, it doesn't actually check that the thing that I'm passing in is of type person. All it does is make sure that it is some object that has a name property and an age property and a dog's property. The dog's property is an array of objects that each have a name string. As long as that's true, it doesn't actually care what the named type of the object is. That's structural typing. More questions about the TypeScript?
Can you show us if you were doing like a fetch or something like that?
Yep.
What would be required?
Totally. So this is probably about as far as we'll get with TypeScript in the program. The only thing that really happens different with things like promises is we need to tell it more about what we're getting back. So if I'm doing the Pokemon API, for example, I might do fetch PS pokeapi.co/API/v2/Pokemon/Pikachu. And then I take the response and parse it. Notice I didn't have to type anything in there because it knows what comes back. TypeScript can figure out what comes back from fetch. And so this is actually already typed. And then I take Pikachu and do something like I'm going to do inner HTML is Pikachu.sprites.frontDefault alt is Pikachu.name and cool. Ta-da! We didn't even need to do any specific TypeScript stuff. Now, TypeScript doesn't have any way of telling what the type of something it gets back from an API is. So, you can help it a little bit by saying, there's a type called Pokemon, and it's an object that has a name property. That's a string. It also has a sprites property, which is an object that has a front default property, which is a string. Has lots of other things too, but it at least has that. And then I could say that Pikachu is of type Pokemon. And like that helps a little bit with knowing what isn't allowed on here. Yeah, that was basically just JavaScript. Now, the thing Parnell was asking about earlier is that when I do query selector, TypeScript doesn't know what kind of elements I'm going to get back. And so you need to tell it. And so the way you do that is with this special syntax with these braces. These are called generics. It's a function for types. That's all it is. I'm giving it an argument, telling it what type it will get back. So in this case, it's HTML div element. And that will let me know that app doesn't have a source attribute. Property source does not exist. Oops. Property source does not exist on type HTML div element. Now, if I told it that it was a image element, now all of a sudden I can do source all day long because image elements have a source attribute. So like you don't need to know how to like make things with generics. All you really need to know how to use right now is how to use them. And that's what that looks like.
So even if we didn't have to create the type of Pokemon with a name string, property, sprites, etc., even though we didn't have to do that to get the image of Pikachu on the page, I imagine for our group project, you'd still at least probably like to see us using that.
Correct.
Okay.
And the strict compiler will be way meaner about this than Parcel is. So if I move all of this into some gerbil script, where do I have that going? All right, so I make an index.html file. Go into that index.ts. Put all this stuff in. Go to my index.html. Okay, so like right away, it's mad about something that Parcel wasn't, for good reason too. Who has done enough query selector with TypeScript to know what that red squiggly is going to be?
Oh, that it may not exist.
It may not exist. Every time you query selector something, it doesn't know whether or not it will actually find anything. If it doesn't find anything, it'll return null. If you call .innerHTML on null, your app will break. So this is telling you, hey, this is possibly null, just FYI. And so the way that you get around that is that you need to test whether or not it exists. So like, if app then do this. Now it's not mad at me anymore. App can't be null in here because TypeScript can kind of follow your logic a little bit. It knows that you can't make it inside this block and have app be null. And so it stops worrying about that.
Can you do that with a short circuit? Say like
good question.
App,
I'll bet you can.
App and app.innerHTML.
And why is it and?
Well, because if the first app is true, it'll immediately go to the next one.
Yep. And do you remember the name that I gave you for that?
Nope.
Precondition. Yeah, I was worried about that. The reason it won't let me do that is because short circuiting only works with expressions. This is a statement. Good instinct, though. What I could do, I could make a function called like display display content. What a great name. That takes in a HTML div element, so we'll call that container, and some content. That is a string. Cool. So then I do this. It's like container.innerHTML. And oops. I'll say Pokemon is of type Pokemon. We'll make this display Pokemon. Pokemon. All right, so then I'll bet I could do this to short circuit. I could say app and display Pokemon with app and Pokemon. I'll bet that works. Maybe? Oh, Pikachu. Hey, that worked. It's because that's an expression. It also happens to be a statement, but that's kind of like in the weeds of JavaScript syntax. It's hacky that we're allowed to do that, but it works. Let's see what happens if I don't explicitly type the Pokemon there. It lives with it. But yeah, I think you will make fewer mistakes if you explicitly type some of these things. Because like if I, for example, declare that as the type, and then do something like that accidentally, womp womp. Front default doesn't exist on type Pokemon. It's because it's inside the sprites. Just something to help. And also, this is, you've already been using some of this stuff. Even when you're writing regular JavaScript and VS Code, all those errors you get are TypeScript errors. It just runs it through a TypeScript compiler as JavaScript and tells you what it finds. More questions?
Mine's not really a question about this, but it's more of a commentary on, is there something about TypeScript that makes it faster than JavaScript in this? Only because this is the first time I've used vanilla JavaScript where it's not crawling the whole time.
Oh, interesting.
So I'm just wondering if there's something about it that makes it less quirky.
No. In fact, check this out. So this is the TypeScript code. If I compile this, watch what happens. npx tsc index.ts. So that runs it through this process, took my TypeScript file. I just ran my TypeScript file through the type checker and got the JavaScript out the other side. So now I have this index.ts file and an index.js file. If I open up that index.js file, check out what's inside. It's almost the same code. Turn that into var. like sort of un-arrow function some of my stuff. But really, this is the same stuff. All it did was yank out all of the things that have anything to do with types. That type checker makes sure that all of your code's types work together okay, and then it gets rid of all the code. Because your browser can't run TypeScript, but your browser can run this.
When you're doing then chains and you have like functions in your then chain, like right after another, do you have to annotate your return values?
No, but you do need to, like, so if I break this out of this like arrow function into a standalone function, let's see, this would be parse JSON. And it's going to take in a response. It's going to return response.json. Okay, so I don't need to annotate the types on this one because TypeScript already knows what comes back from fetch. This function, though, has no idea. This response could be coming from anywhere. I could just be calling it by hand. It doesn't know that that came specifically from a fetch kind of thing. So this standalone function needs more data. So as you figured out earlier today, this is looking for a capital R response. And by the way, all those types, I think this is dumb for what it's worth, but they're on MDN. There is no like good TypeScript like encyclopedia for this. So what you do is you look at the function on MDN and you go, okay, what does it return? Those are its parameters. And its return value is a promise that resolves to a response object. The capital R is your hint that that's what the type is. All right, so what comes back from response.json? Return value is a promise that resolves to an object. So we could annotate the type on this. The way you annotate the return value of something is like after the parentheses for the params. So we could say this evaluates to a promise that evaluates to a Pokemon. And then we could use parse JSON. We could do that. That works. I don't know if it makes you annotate the return type on this. Yeah, it lets you get away with it. But you could, like, that would probably make a little more sense in this situation. More questions about this? It's really not that bad. In a lot of ways, it even just, with like the improved quality of the error messages and stuff you get, it's even a little bit easier than JavaScript a lot of the time. And as far as stuff that like we really need to have our heads around right now, basic types like string Boolean number kind of stuff. We need to know how to annotate parameters on functions. We need to know how to make objects. And we need to know some very simple DOM manipulation stuff. It's all the stuff that we just did. So like annotating these generics Same thing when you make an element. There's an example of how to do fetch with the types. We just did one of those too. If you need to send any data, that's how you would do it. And then if you try to just add some random variable to the global scope, that's not allowed in TypeScript. If you want to do it anyway, that's how you do it. And here's a big old list of all the most common types for elements. That's it. You can do all those things. You probably know as much TypeScript as like 90% of people that put TypeScript on their resume. I also have a guide here for how you can do TypeScript Ingest. Like 99% of the time, you can just make your TypeScript test a like .spec.ts file, and then that's it. You don't need to annotate almost anything in TypeScript. It's pretty, or in Ingest. It's pretty rare that you need to actually add the types to something. This is the one situation where you do when you're mocking modules. Otherwise, everything else just works like normal. More questions? Highly recommend going through some of these practice exercises in TypeScript. Very good place to just sort of get your sea legs with this. Especially ones you've already done before, so you're not also worried about what the logic of the problem is. See if you can get it working in TypeScript. Anything else we need to talk about?
This doesn't seem so bad anymore.
No, it's not that bad. It really isn't. To give you an idea of where we're going, and also if you've been through the TypeScript handbook, you may have seen some stuff with classes and interfaces and decorators and like a couple of those things. We don't need to do any of that for Pokemon. We don't need to do any of that for Unit 3. That's what we're starting the next unit with, is expanding our TypeScript vocabulary. But even then, we're still just doing all of these exact same things, just in a different syntax. All right. Well, that's what I got for you. I can't figure out why I can't unscreen share. It won't let me do it. But whatever. We're done. Go learn something.